Hello guys, how are you? I hope you're fine and you might be doing very good. Welcome to the channel VIBGYOR of Talents. So in today's video we are going to look at the chapter Quadrilaterals. So it's the part 3 of class 9 NCERT, or we can say also as CBSE. Okay, so it's from the mathematics subject. By hearing the name of quadrilaterals only, you might be pretty sure that it's from the subject of mathematics. Okay, so these were the previous videos of VIBGYOR of Talents. In the part 1, we knew about what we had already knew before from the classes. We just had a quick revision. And in the second part of the video, we have seen different types of quadrilaterals. We have learned different types of quadrilaterals. So I would like you to watch these videos and then continue to watch this video. If you have already watched it, it's great. But if you hadn't watched these videos, you might not understand this video pretty clearly. So I recommend you to watch these videos and then watch this video. So you might be worrying how to watch this previous videos. Don't at all get worried. The links are in the description. If you hadn't watched it, you can watch it right now. Okay, so in today's video, we are going to look at one of the major concepts, the properties of a parallelogram. So everything has some properties. In chemistry, you might be learning about physical properties and chemical properties. For human also, there are two properties, the physical properties, and human also have emotional properties. So parallelogram is a non-living thing. It can't go and dance, right? So it's a non-living thing, but we can go and dance. So we are living things. We have both emotional and physical properties, but whereas the parallelogram only and only has physical properties. So that physical properties that we are going to learn about parallelogram today in this video. Okay, so let's learn it in the form of theorems, which would be easy. So first of all, let's perform an activity. Let's learn them through an activity. Let's perform an activity. Cut out a parallelogram from a sheet of paper and cut it along a diagonal. So you obtain two triangles. So what can you say about these triangles? What will you obviously say by looking at these triangles? You will place one triangle over the other, turn one round if necessary. And then what do you observe again? The parallelogram will look something like this if we draw a diagonal. But I can't show you how to fold it, so I'm just showing in this way. Okay, so it looks something like this. So we observe that the two triangles are congruent to each other. So repeat this activity with some more parallelograms. Each time you will observe each diagonal divides the parallelogram into two congruent triangles. So let us now prove this result. So let's get it in the form of a theorem. So this is theorem 1. Consider it as theorem 1. So what is a theorem 1? A diagonal of a parallelogram divides it into two congruent triangles, equal triangles. The diagonal converts it or divides it into congruent triangles, the parallelogram into two congruent triangles. So let's try to prove it with the help of a proof. Okay, so let ABCD be a parallelogram, as you can see here, and AC be a diagonal. And observe that diagonal AC divides parallelogram ABCD into two triangles, namely the triangle ABC, the lower one, and triangle CDA, the upper one. And we need to prove that these triangles are congruent. So you have already learned in the previous chapter of triangles how to prove this congruency. So basically there are three main types, that is SSS congruency, SAS congruency, and ASA congruency. There is one more type, that is RHS congruency, which almost comes under SAS congruency. Okay. So how can we prove that these triangles are triangle ABC and triangle CDA are congruent? Let's try to see what are equal in the both triangles, and let's try to do it. So what do you observe here? In triangle ABC and triangle CDA, we note that BC is parallel to AD. Of course, in parallelogram they are parallel. What is the definition of parallelogram that we learned in the previous video? Both the sides are parallel to each other. And If you see here, we have AC as a transversal in it. So what can we write from it? We can write as, so angle BCA is equal to angle DAC. What is the reason that we are able to write angle BCA is equal to angle DAC? It is due to the pair of alternate angles. And also we know that AB is parallel to DC and also AC is a transversal. So again angle BAC now is equal to angle DCA. What is the reason? Again the same reason, the pair of alternate angles. And the last one, the last common thing that we have is AC is equal to CA. So why are we considering it? It's just the common side between them. So we can write it as AC is equal to CA. So now we have proved it, the congruency. So triangle ABC is congruent to triangle CDA. So how did we prove it? With the help of angle side angle rule, we have proved it. So we can write it in just another simpler way, like, or the diagonal AC divides the parallelogram ABCD into two congruent triangles ABC and CDA. So that was the theorem 1 that we had. We have proved it. What is the theorem 1? The diagonal of a parallelogram divides it into two congruent triangles. Now we have proved that this transversal or the diagonal that we have, that is AC, divided the parallelogram into two parts, and so triangle ABC is congruent to triangle CDA by ASA, angle side angle property or rule. Okay, we are done with the first theorem. So now I would like you to measure the opposite sides of this parallelogram ABCD. So what do you observe from that? You will find that AB is equal to DC and AD is equal to BC. So how are we going to get that? We know that they are equal, but we should prove it in some way. So this statement can be written in the form of a theorem, like in a parallelogram opposite sides are equal. So let's make it as theorem 2. What is the theorem 2? In a parallelogram opposite sides are equal. Okay, and then actually you have already proved that a diagonal divides the parallelogram into two congruent triangles that we have seen just before. So what can you say about the corresponding parts? Say the corresponding sides are equal. Yes, we can say that they are equal. So AB is equal to DC and AD is equal to BC. Yes, we have proved this also now very easily. Now, what is the converse of this result? So we already know that whatever is given in a theorem, the same is to be proved in the converse. And whatever is proved in the theorem, it is given in converse. So thus, the theorem 2 can be stated in other way also. So it can be stated as the theorem 3 that we name it here. It can be stated as, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So here comes our theorem 3. They are both same, but it's the converse of it. So we should also verify if the converse is also applicable. So can we reason out why? So let's take the sides AB and CD of the quadrilateral ABCD. Let's make this quadrilateral. Let's name this quadrilateral as ABCD. This quadrilateral that you see here, and be equal, and also AD is equal to BC. Now we should draw diagonal AC. Okay, so what do you get from here? Clearly we know that triangle ABC is congruent to triangle CDA. So angle BAC is equal to angle DCA and angle BCA is equal to angle DAC. So can you now say that ABCD is a parallelogram? Why? But why? So actually we have just seen that in a parallelogram each pair of opposite sides is equal, and conversely if each pair of opposite sides of a quadrilateral is equal, then it's a parallelogram, as simple as it. So now can we conclude the same result for the pairs of opposite angles? Again, draw a parallelogram and measure its angles. What do you observe? Each pair of opposite angles is equal. Repeat this activity with some more parallelograms and you arrive at another result, as you can see, which can be stated as the theorem number 4 for us. So it is, in a parallelogram, opposite angles are equal. So let's see how it is possible. You be obviously knowing that all the angles, the opposite angles in a parallelogram are equal. Now let's try to ask another question. Now, is the converse of this result also true? Yes, the converse of this result is also true. Using the angle sum property of a quadrilateral and the results of parallel lines intersected by a transversal, we can see that the converse is also true. So we can have the following theorem with the help of it. It's the theorem number 5. So that is, if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Okay, now we are done with theorem 5. Let's explore something more. So there is yet another property of a parallelogram. Let us study the same now. So draw a parallelogram ABCD and draw both its diagonals intersecting at the point O. And then measure the lengths of OA, OB, OC as well as OD. So what do you observe? You will observe that OA is equal to OC and OB is equal to OD. Or we can also write it as O is the midpoint of both the diagonals. So I want you guys to find out how can we state out this theorem, that is theorem number 6. So I'll be back with another video of this continuation, and if you get the answer that what is the theorem number 6, let me know in the comment section and I will give the shout out of the first person who gives the theorem. And let's see if you are right in the next video. So that is it for today, guys. Thanks a lot for watching this video and have a very great day. Thank you once again, and please do like, share and subscribe to VIBGYOR of Talents.